Hi everyone. We are Team 29 from Nanyang Technological University. The problem we want to solve in this year's NUS-MIT Datathon is the domain shift problem in chest X-ray diagnosis AI models. Common deep learning-based diagnostic models use the chest X-ray images as inputs. The inputs are then passed through a convolutional neural network to extract valuable features. The prediction layer will map the extracted features to the corresponding disease labels. In this datathon, we selected 3 datasets from the list for study the domain shift problem. They are chest X-ray 8, Che-Expert, and Mimic CXR-JPEG. Here are some statistical information of these 3 datasets. We selected 4 common convolutional neural network architectures training on the selected 3 datasets. The chart shows the single dataset supervised performance for each dataset, and we observe that as models getting more complex, the performance improves. However, in the real-world deployment, an AI models trained from the dataset collected from one hospital will be deployed in various hospitals directly. In this process, the domain shift problem of the diagnosis AI models will occur. The hospital in which the training data is collected is called the source domain. A well-defined AI model can achieve good performance when training and validating within the same domain. However, when the model directly used in the target domain, some of the data will be misclassified due to the domain shift. The domain shift problem is usually caused by 2 factors: different patient distributions, and the variation in clinical environments. The image acquisition protocols and machines may vary among diagnostic centers. The diverse patient population of each hospital and clinic is also different. To solve this problem of performance degradation between different domains, we propose to use domain adaptation or domain generalization methods to reduce the domain gap during the training. In this datathon, we experiment with 2 simple approaches to alleviate the problem of performance degradation during the cross-dataset or cross-domain evaluation. In order to perform the cross-dataset evaluation, we need to figure out the common labels between the 3 datasets. There are a total of 8 labels common share between chest X-ray 8, Che-Expert, and Mimic CXR-JPEG. Since we treat the AI diagnosis problem as a multi-label classification problem, we believe that the no-finding label can be removed in our training and testing. In the following experiments, the performances of each dataset are all based on the 7 common labels. In the previous slides, the more complex neural networks usually yield better performance. However, it may not be the case in the cross-dataset experiment. The following figure shows one of the results we obtained during the datathon. As the backbone models getting more complex, the Che-Expert trained models show stable improvement when testing in the same Che-Expert dataset. However, the chest X-ray 8 trained model when uses the DenseNet 121 could not surpass the small ResNet 18 network when evaluated in the Che-Expert dataset. The next experiment is designed to demonstrate the cross-dataset performance across the different datasets. We fixed the network architecture to ResNet 18. We can clearly see that deep learning models perform best when training and test happen in the same domain. When using the models trained from another dataset, we can see obvious performance degradation compared to the single-domain trained models. It clearly illustrated the domain shift problem inside the X-ray diagnosis AI models. In this datathon, we selected a well-known maximum mean discrepancy (MMD) method to reduce the domain diversity between source and target domains. For the domain generalization method, we integrated our LDDG approach during the training. Our LDDG was accepted in this year's Neural Information Processing Systems Conference. There are the results we obtained after overeating the MMD regularization and our LDDG module. We can see that both domain adaptation and domain generalization approaches do help to boost up the cross-dataset performance. The MMD regulation did not help a lot for the Che-Expert to chest X-ray 8 experiment. But our LDDG approach shows consistent improvement in these 2 experiments. However, due to the time constraint of the datathon, we don't have enough time to complete the rest of the experiments for other dataset pairs. To summarize this presentation, we firstly raised one problem in medical image diagnosis AI that domain shift tends to implicate in poor generalization performance. Our experiments demonstrate the cross-dataset performance degradation by using 3 provided datasets, Che-Expert, chest X-ray 8 and Mimic CXR-JPEG. We managed to alleviate the problem by using the domain adaptation method, MMD, and domain generalization method LDDG. Owing to time constraints, we cannot complete all the experiments we planned initially. But we will introduce more datasets and various domain adaptation and domain generalization techniques in medical images. We aim to produce a full evaluation of the effectiveness of various DA and DG methods. We are also interested in the cross-modality chest X-ray AI models, such as X-ray to MRI or MRI to X-ray. Thank you for your attention.